Today we are talking about formulas that you can use with three-dimensional shapes. First, we need to identify what is a polyhedron and what is not a polyhedron. A polyhedron is formed by four or more polygons that intersect only at their edges. Prisms and pyramids are polyhedrons because they are made up of polygons. But cylinders and cones and spheres are not polyhedrons because they are not made up of polygons. Our first formula that we use for these is called Euler's formula. For any polyhedron with V vertices, E edges, and F faces, you can use Euler's formula, and it is V minus E plus F equals 2. This is really useful because while we might be using a 3D drawing or even a 3D shape and we are trying to count all of the vertices, edges, and faces of that 3D figure, sometimes we make a mistake. Either you count one twice or you forget to count one, and so you can always verify whether you've counted the correct number of vertices, edges, and faces by plugging it into this formula. For example, if you had a triangular pyramid, you might go through and count and find that you have 4 vertices, 6 edges, and 4 faces. If you plug that into Euler's formula, you get 4 minus 6 plus 4. If you solve the left-hand portion of this equation, you will then find that you get 2 equals 2. Because that is a true statement, Euler's formula verifies that there are indeed 4 vertices, 6 edges, and 4 faces. If, however, you had miscounted, you might have gotten something like 5 equals 2. Obviously, 5 and 2 are not the same number, so Euler's formula would tell you that you had made a mistake in counting somewhere, and you would need to go back and double check that. Our next formula is to find the diagonal of a right rectangular prism. The length of a diagonal of a right rectangular prism with length L, width W, and height H is D equals the square root of L squared plus W squared plus H squared. This is based off of the Pythagorean theorem. And you will notice here that there is a right triangle inside this prism. This formula, to use this formula, you will plug in the length, the width, and the height. You square each of those and add them together, and then you take the square root, and that will tell you the length of the diagonal of this right rectangular prism. So again, that would help you identify the length of this diagonal. Notice that your diagonal starts in one corner, or at one vertex, and it is going to cut across the shape. Okay, so it's going to the back. This one's at the front, we're going to the back. And it's going down. So this is the top left-hand corner, and we are going to the bottom right-hand corner at the back of the figure. So that diagonal does have to cut across the shape. And the two resulting shapes here then would be 2 triangular prisms. So you can keep that in mind, that your diagonal has to cut all the way across that entire shape. Next, we're going to be dealing with a formula that helps us find distance in space. Up to this point, when we've used a distance formula, it is for a 2D figure, okay, or a flat shape. In reality, we have all of space to contend with, and we need to actually be able to figure out distances in 3-dimensional space. This is much more realistic and much more useful in life because, for instance, if you were measuring the distance that a plane has to fly from the Waco airport to Dallas, to the DFW airport, you would not just be, calculating a straight line. There's height and width and depth that all go into that, and so you would need to be able to use all 3 dimensions to find that length. So this is our distance and our midpoint formulas for use in 3 dimensions. And so you'll notice both of these formulas look very similar to what we had before, only we've added an extra dimension. So before we had x2 minus x1 squared plus y2 minus y1 squared. And now we've added on the plus z2 minus z1 squared. And that's just that third dimension. So again, z is just that third dimension here. And you'll notice that in our picture, they've added z as our extra axis up here also. Same thing with midpoint. You still have your x1 plus x2 divided by 2, y1 plus y2 divided by 2, and now you also have z1 plus z2 divided by 2. And again, your coordinates will be written with 3 coordinates instead of just an ordered pair. So that's one of our other differences. Thank you very much. Don't forget to answer the quiz questions at the end.